Good morning. It is Thursday, May 28th, and today I can prove triangles are similar using circle theorems. So, last lesson we did proving triangles congruent. This one we're doing triangles similar. We have a different song, even though the other song is kind of incorporated into this, but we have a different song for similar triangle proofs. So, let's hear it.
Similar AA, similar AA, similar AA. Work backwards when you have proportion is the step. Multiply CPE. Proportion is the step. Multiply CPE. Proportion is the step. Multiply CPE. Proportion is the step. And multiply CPE.
Yeah. So, if you no.
Sine A.
So, if you where am I? So if you are asked to prove a proportion or multiplication, we're going to work backwards. And it's similar AA, proportion CSS tip, multiply CPE. Now CPE is not good enough on its own. What CPE stands for is cross products are equal. So these are the notes that's in the front of the packet, and we're literally just following the script. If we're asked to prove multiplication, let me get my pen up here. If we're asked to prove multiplication at the bottom, what is going on here? I want my pen. Pen, 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 pen. If you're asked to prove multiplication, you go at the bottom, you put cross products are equal. Above that, we start with a blank proportion. Whatever's being multiplied, since they're being cross multiplied, they're going diagonal from each other. So AE and EB must be diagonal from each other. Same thing with CE and ED. So it doesn't matter exactly where they go, as long as they're diagonal from each other. The reason for the proportion is always CSS tip, and the ST in CSS tip stands for similar triangles. So before the proportion, I'm saying the triangles are similar, and the reason for similar triangles is always AA. CSS tip stands for corresponding sides of similar triangles are in proportion, but writing CSS tip is fine. So use this as a model. Again, we've done this lesson earlier in the year. Now we're just going to incorporate circle theorems into it. But if you understand what we did last lesson and you understand this from when we initially did it, this should be an easy lesson for you. So let's see if I can get this a little bit smaller so we can actually write. I know it's kind of hard for me to keep everything neat here, but I'll do my best. So we're being asked to prove a proportion. Let me try and type it this time. Let's just write out the statements and the reasons. Now I'm going to write it. Whenever I'm asked to prove a proportion or multiplication, I'm going to work backwards. So at the bottom, I'm going to put TE over TY equals TL over TR. And the reason for the proportion is CSS tip. Now I'm working backwards. Because it's not asking me to prove multiplication, I'm not going to do the multiplication step. What comes before the proportion? The similar triangles. So is it obvious which triangles I'm proving similar here? It is to me, but in case it's not, if you remember, we can look at the letters, look vertically and look horizontally. TETL, TEL. TEL is a triangle, so that's going to be one of them. Then the other one, TYTR, TYR. That's your triangle. So it's going to be triangle TLE is similar to triangle TLE, TRY, and the reason for similar is always bigger. So now I can start from the beginning. I know that I'm proving the blue and the green triangle. So what givens do I have here? I see YR is perpendicular to TE. Given, nothing else useful. So I know that perpendicular forms right angles, YR and TE. These are my right angles. Now, are they both angles of the triangles we're trying to prove? No. This is an angle of the blue triangle. However, this other one is not an angle of the green triangle. So that one's not going to help us. So that perpendicular only gave us one right angle. I need another right angle. So I'm going to look for my circle theorems. Inscribed. Do I see inscribed? Well, I see something going on here. I see a tangent and a diameter. And I learned that a tangent and a diameter form right angles. So, angle TLE is congruent to angle TRY. Now, the reason this one's going to kind of be a mouthful. So, let's see if I can type this one. It's going to get long and sloppy, and there's not a lot of space to work here. This is a problem in class. I'd be writing the problem on the board and marking the picture on the smartboard, so it's a little tricky here, but we'll get by. Let's make the font a lot smaller. So we're kind of combining two reasons into one here. This right angle came from perpendicular lines. This right angle came from a tangent meeting a diameter. So I'm going to say that perpendicular lines and a tangent intersecting with a diameter form congruent right angles. So I'm kind of combining two things there. That's it. So I have one pair of angles congruent at this point. I need two pairs of angles congruent. Inscribed's not going to help me. Radii, not going to help me. Diameter, not going to help me. So I go to my additional tools, VRIAS, V, vertical angle, don't see any. R, reflexive property, yeah. Look for the reflexive property. Is there a side or an angle in both? Keep in mind that similar is always angles, so you're only looking at angles. Yes, I see an angle that's in both triangles. Angle T. So I'm going to state that angle YTR is congruent to angle YTR, reflexive property. Now that I have angle, I can state that triangles are similar, their proportion, and again, since this one asks for the proportion, I don't have to do the multiplication step. And that's it. And that's it. Let's skip ahead to number 3. This one's got a little something you've never seen before. Just a little something. Make this a little bit smaller if I can. So in order to save space, this is all nothing. It wants me to prove this. Statements. And this was definitely a hard question, don't get me wrong. It wants me to prove multiplication. So, also understand squared. Too messy. AC times AD. AB squared means AB times AB. Multiply CPE. So at the bottom, AC times AD equals AB squared. The reason for multiplication is CPE. Cross products are equal. Before the multiplication, let's clean this up a little bit. Before the multiplication is the proportion. So I start by making a blank proportion, and whatever's being multiplied must be diagonal from each other. So the AC and the AD must be diagonal because I'm cross multiplying. That's where the multiplication comes from. And AB and AB must be diagonal from each other. And the reason for the proportion is C as this tip. Now before the proportion, I'm proving triangles are similar. Is it obvious which triangles I'm proving similar here? Well, I have a problem. I don't see triangles. So what we're going to have to do is we're going to have to draw in what we call auxiliary lines to make triangles. So I can draw in this line that makes triangle ABD, and I can draw in this line, and that makes a triangle as well. So that's new. You've never seen that before. Save it to the end of the year for something new in proofs. It's a very small thing. It doesn't come up much, but it did come up in this problem, and it's going to come up in the next problem as well. So if you ever need to draw in auxiliary lines, my statement is going to be what I'm drawing in, BD and BC, and the reason auxiliary lines can be drawn. So, what triangles am I proving similar? We're going to look to see which triangles I need to prove here. So, no matter which way you look at it, AC, AB, AB, AD, we have ACB, and we have ABD. So, triangle ACB is similar to triangle ADB. AA is always the reason for the triangles being similar. So let's see if I can do something with this here. So I know we don't have a lot of space. Nope, it didn't work. All right, so let's just look at by. So I don't have anything in the givens, so I'm going to need my circle theorem. Inscribed. I'm looking for inscribed. Well, I have D that's inscribed to BC. Now look here. I have this, which is, we call it our special case. It's not technically inscribed, but it is on the circle. It is intercepting the same arc. Therefore, they must be congruent. So that's going to be one thing. My second thing, reflexive property. That angle is in both the red and the blue. So can I fit this in here? I'm going to try. I've got angle BDC is congruent to angle ABC. Angles inscribed to the seam arc are congruent. And then I have angle A is congruent to angle A, reflexive property. Once I have my two angles, I can state the triangles are similar. I can state the proportion, CSS tip. I can state the multiplication, CPE, or cross products are equal. So again, whenever you're being asked to prove multiplication, work backwards, follow this script. It's going to always be the same, just the letters are the only thing that are going to change. And once you get to this point, to prove triangles are similar, we need to prove angle. Our circle theorems look for inscribed central or inscribed radii and diameters, inscribed especially, and go from there. I'm just going to give you a hint on number 4. We're going to need to draw auxiliary lines. So I would draw CB and AD. And you know what? Let's do it together, partially, because I want to make sure you're able to do this. And that's way too big. So let me see what I can do here. Same thing. This is all nonsense. This is all irrelevant. So let's kind of utilize the space there. It wants me to prove multiplication. So when you're proving multiplication, we work backwards. And what I want to see right now from you is I want to see your bottom 3 steps. Use this as a model. Use this as a model. It's the same thing. I want to see your bottom 3 steps. I'm going to give you a couple minutes to do that. If you need more time, hit pause. Multiply CPE. The reason for multiplication is always cross products are equal. The multiplication always comes after the proportion. So I make a blank proportion. Whatever's being multiplied must be diagonal from each other. So AE and EB must be diagonal from each other. And CE and ED must be diagonal from each other. And the reason for the proportion is always CSS tip. And before the proportion is always prove similar AA. So which triangles am I proving similar? Well, again, I need to draw on those auxiliary lines. That was my hint to you. So this one's pretty clear to see. I think easier than the last one. Triangle BCE is similar to triangle DAE. And the reason, prove similar AA. That got a little messy. In fact, yeah, whatever, we'll deal with it. Now that you have that, you know you need to prove those two triangles are similar. You need to prove AA. I'm going to give you a couple minutes to try and get those two angles. Then we'll go over it, and that will be it. If you need more time, press pause. There's no givens, so I'm looking for my circle theorems, inscribed, radii, diameters, inscribed. I see C is inscribed to BD. See A is inscribed to BD. They must be congruent. I see B is inscribed to CA. I see D is inscribed to CA. Those must be congruent. So, angle BCE is congruent to angle DAE, and angle CBE is congruent to angle ADE. Angles inscribed to the same arc are congruent. That's all I need. We also do have vertical angles here. We don't need that. We already have angle, but you could have used the vertical angles. So once I have my two things, the triangles are similar, the proportion, CSS tip, the multiply, CPE. And that's it. And that's it for proofs. And that's it for the course, pretty much. We have one more lesson after this. You'll have a quiz on this, so your classwork / homework. There's only one more question to do. So I'm going to say that your classwork / homework is to finish worksheet / practice. Today is Thursday, so your quiz is going to be due Sunday night. Any questions, reach out to me and remind. Again, to prove triangles similar using circle theorems. To prove triangles similar, that's AA. To prove proportion or multiplication, we work backwards. We follow our song. We follow this script. We work backwards. And once we work backwards, up until we have the triangles being similar. Again, any questions, reach out to me and remind. And have a great day.